Alright guys, I want to show you real quick how to take your CO2 racer models from Onshape, import them into SimScale, and start setting up a simulation where we can figure out what an estimate of the drag coefficient for your racer is going to be. So here I've got just my part studio in Onshape. I've got three CO2 racer designs down here. I'm going to see if I can simulate the dynamics of this box racer model. The easiest way I've found to do this is to export this as an STL file. STL file preserves volume measurements a little bit better than the other formats. One thing you have to be careful here is SimScale defaults to meter units. So whatever you did your units in, creating your designs is fine. If you select meter as your units, you'll have a little bit easier time importing this into SimScale. So hit OK. It's going to download it. We can switch over to SimScale. So the SimScale software, once you create a new project, is going to look something like this. The first thing we need to do is to add what's called a geometry to the simulation. So this is just going to be the physical representation of what we are simulating. So we just downloaded an STL file which stores volume information. So I'm just going to add that file here. So there's my box racer. I'm going to hit upload. It's going to take maybe a minute or two to upload this file, so hang tight. Alright, once you've uploaded your file, you should see something like this. Just looking at manipulating the geometry in SimScale, there's a couple options up here. You can click and pan just the same way you do in Onshape. There's a couple options up here that let you select different things. So the select face lets me select the two-dimensional face. The select volume lets me select that entire volume. So just be aware that those tools are up there because this will come into play here in a minute. So cool, that looks great. I'm going to go down here to simulations and let's go ahead and create a new simulation. So there's a lot of options here for simulating a variety of physical systems. When we're talking about airflow and aerodynamics, this is a type of fluid flow. So we're going to choose incompressible fluid flow option up here. There are other options down there, but this one tends to work the best for airflow. So I'm going to create a simulation, and you'll see a whole bunch of stuff pops up here. If you go to geometry, it just says it's building this simulation based on my box racer geometry. So it's pretty simple. Gives you a description of the different nodes. So it's like the vertices, 12 edges. So that's of course the edges in between the faces, the flat faces, and one volume. Alright, so before we can run a simulation, we need to create something called a mesh. A mesh is just going to be, it's just going to build up the number of points that we're going to use to calculate the physics of the system. So it's going to be like points in the XYZ planes. So there's options here for creating a mesh. The default settings for your mesh will be fine. Hex dominant works pretty well. What we want is an external sizing. So we're going to, obviously, if we're talking about airflow, we're talking about the flow of material outside of the volume. So I'm going to choose external. Course should be all right. Let's see. Before we hit generate, don't hit generate quite yet. We're going to set up a few parameters here. And the first thing we're going to look at, if you open up geometry primitives, there's something called a background mesh box, and that's just going to be the volume that we're going to let airflow through. And so looking at the setup, it's probably a little bigger than we need it to be. If we size this down a little bit, our simulation will run a little bit better. And so you can play around with these. I'm going to use say negative 0.2 meters, so that's like 200 millimeters in the X direction. You can look down here if you want to see the orientation of the axes. Let's see, Y in this case is going to be back into the screen. That probably looks fine to me. As the axis is looking up and down, so that looks alright, I think. Let's make the maximum x-axis distance, let's say 1.83. Let's try 0.4. That'll shrink things down a little bit. We'll get a slightly faster simulation and hopefully still be able to see what's happening with the aerodynamics of this very, very simple design. All right, one thing you can do if you want to, I'm not going to require this, but is to add refinements. And so refinements are going to be parts of your diagram that are more detailed in the simulation. If you want to add a region refinement, you could pick the volume, and that'll give you more refined mesh box around that volume. And so let me call this, let's call this racer volume. It'll add some time to our simulation, but hopefully that's going to be somewhat negligible at this point. All right. So that's all the settings I'm going to use for my mesh box right here. So let's hit generate. And again, this is going to give you kind of an estimate of how long it's going to take. This is a fairly computationally intensive task. And so this is cloud-based software. So SimScale's servers, they're essentially giving you CPU hours on their servers. I think with the free account you get up to 3,000 core hours. So I'm going to pause this right now, give us a second to load, and back to you. Alright, so once your mesh is finished generating, you're going to see something like this. And we're going to use this mesh as the domain for our simulation. But a few things we are going to just take a look at. It just looks like a big block of a bunch of cubes. These cubes are where we're going to, like, the software is going to run its mathematical calculations on. We can take a closer look at this. You can change your view options up here just to make it easier to look. And you can see the background mesh box, which is essentially going to serve as a wind tunnel for our simulation. You can see the racer inside. One thing you might play around with taking a look at, I can do a mesh clip, which is just going to take a plane and slice through part of this. So if I clip through this, I just still cut this thing in half, and now you can see what's going on inside a little bit better. And you can see I turn the refinements on. You can see how the mesh gets finer and finer as we get closer to the actual racer, which is going to be a nice feature for getting some detailed simulations around the racer itself. So that's everything you need to know about setting up your mesh and getting your project ready to simulate. We'll take a look in the next video at actually running a simulation, setting up some simulation parameters, and seeing how well this thing performs.